Hi everybody, I'm doing 16.2 in Honors Chemistry. We're going to talk about acid-base equilibria. First of all though, I would just like to remind you of some of the equations that have to do with acids. We already talked about neutralization. That's when you have an acid like hydrochloric acid plus a base like NaOH. These are both strong, okay? And strong refers to how well they dissolve. And these will do a double displacement reaction, so you end up with a salt and water. That is called a neutralization reaction. Then I want to remind you, and this neutralization reaction, when we start talking about indicators, that's basically what we did at the Elizabethan feast to turn the water into wine. We put some phenolphthalein in there, which I'll be talking about a little later, which is an acid-base indicator that changes color right around pH 8, which is just a little above neutral. And when you have acid we used acetic acid, which is basically white vinegar, and we added some sodium hydroxide until it had a pH of higher than 8. And we'll be talking about pH today. And that changed the color to pink. So you've seen a reaction, you've seen a neutralization reaction, even though you might not have realized it. Another reaction, I don't know if any of you did this when you were younger, but was the volcano reaction where you did vinegar and baking soda. Well, if you take an acid like HCl and baking soda, I think it's bicarbonate, yeah. Sodium bicarbonate. Whenever an acid reacts with a carbonate, it makes CO2 gas, which is what comes bubbling out, plus a salt and water. So it makes carbon dioxide, salt, and a water when you have a reaction when an acid reacts with carbonate. And the last reaction is also something I want to remind you of the Elizabethan feast. Remember when we did the bubbles and you lit them on fire? Well, that was a classic reaction with an acid and a metal. We took zinc metal and we added acid and we came out with a salt, zinc chloride, plus H2 gas, which is extremely flammable. So when you have a metal with an acid, it creates hydrogen gas. And when we bubbled it through the bubbles and we scooped up the bubbles, inside the bubbles was hydrogen gas. That's why it burst into flame so quickly. So I just wanted to show you these three reactions that have to do with acids. Now, the main reaction we talk about with acids that leads to the pH scale is what's called the autoionization of water. Water, when left to itself, will actually ionize a little bit, okay? And since we've done K equilibrium constant expressions, that's what we're going to do. So let's take two waters, okay? This is liquid. I'm going to do two waters that are liquid, and they form an equilibrium and form hydronium, which is H3O positive, which a lot of times we just use H positive, because what happens is that little extra proton attaches itself to a water molecule and forms the hydronium ion, which is H3O plus. And what's left is an OH ion, which is the hydroxide ion. This is the ion associated with acids. This is the ion associated with bases. So this donates the proton. So this is acting as a Bronsted-Lewis acid, and this is its conjugate base. This is acting as the base, and this is its conjugate acid. So this is called the autoionization of water. And these, of course, are aqueous because ions are always floating around in the water in an aqueous solution. So the KEQ of water is basically, or to keep it simple, the KEQ of water is H plus and OH minus, okay? So it's equal, it's an equal share of each. So if the KEQ of water is 1 times 10 to the negative 14. And so this is X and this is X. So to find out what the concentration of H plus ions is, you get the square root of X. So 1 times 10 to the negative 7 is my concentration of H plus ions. It is also the concentration of OH ions. Now some of you that might be a little familiar with the pH scale might recognize that 7 is neutral. So when you have an equal amount of these and they neutralize themselves, the pH is 7. The pH scale goes as high as 14. That's what that number is. So all the pH scale is the exponent when you change the concentration in a 1 times 10 to the power. And how do you do that? On your calculator, pH is the negative log of the concentration of hydronium or H plus ions. Okay, that's what pH is. Because see how it's negative 14? Because a log, you've learned in math hopefully, is just an exponent. All a logarithm is an exponent. So because it's a negative exponent and the pH scale is all positive, we have to make it the negative exponent. So when you punch that in your calculator, which you'll be doing in order to find things, is you would just hit negative log and then punch in whatever concentration. So if I did 1 second EE negative 7, because that's how you punch in 1 times 10 to the negative 7, and enter, it comes out to the pH of 7. So let's say I had a molarity or concentration of 0.01 is my concentration of H plus ions. Well, I would just do negative log 0.01 and I have a pH of 2. Now notice, the bigger the concentration of H plus ions, the more acidic it is. So the more acidic it is the acidity is based on the H plus ions. If it has more OH ions than H plus ions, then it's going to be basic. Okay? So can we do the same thing with concentrations of OH? Yes, we have something called the pOH scale, which you find by doing the log of the OH ions. And that'll give you the pOH, which means nothing to most people because everybody uses the pH scale. But you can turn it into pH simply by saying the pH plus the pOH equals 14. Because 14 is the highest number. So if you have a pH of 2, you have a pOH of 12. Because 12 plus 2 is 14. So if you are given the concentration of OH ions and they ask you for the pH, you can simply plug the pOH and find it here. Plug in the OH ions into this. Once you find that, do pH plus the number you got equals 14, subtract it, and you get the pH. So that's how you can convert from the pH scale to the pOH scale. All right, I'm going to put the rest on another video because I don't want to make these videos too long.